In physics, we're going to be using trigonometry all the time. Now, you might have had an entire class in trigonometry. Fortunately, there's only 3 facts you need to remember from trig to get through all of physics. Those 3 facts are the definitions of the sine, cosine, and tangent. You may remember this little phrase, SOHCAHTOA. Sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. The second rule is the Pythagorean Theorem. 3 sides of a right triangle, A, B, and C, obey this relationship. And the third rule is that the 3 angles in a triangle add up to 180 degrees. If we know those 3 things, we can do all the trig we need for physics. So let's do a few problems to review your trigonometry. And you might want to just pause the video and try this on your own, and then start it again and watch my solution. So this first example, we've got a right triangle where I've given you one angle and I've given you the hypotenuse. Your job is to find the other 2 angles, A and B, and the other 2 sides, little a and little b. So pause now if you want to try it on your own, and then watch my solution. All right, so let's start by finding angle B. We can use our relationship for the 3 angles. We know that they need to add up to 180 degrees. We have 30 degrees. We've got 90-degree right angle. That must mean that angle B is 60 degrees. Now let's find these sides. And we can use our trig relationships. So recall that sine is opposite over hypotenuse, and this side, little a, is opposite to that 30-degree angle. So we can say sine 30 degrees equals a over hypotenuse, or a is hypotenuse times sine 30 degrees. We're given that the hypotenuse has a length of 7. So side A equals 3.5. So we've got sides A and C. We know all angles A, B, and C. So to figure out side B, you actually have several ways you could do it. You could either use your Pythagorean theorem to solve for B. You could use another trig identity to solve for B. It's up to you. So try it one of those ways, and you should find that side B equals 6.06. Now keep in mind, when we are doing calculations with your calculator, it needs to be in the correct mode. If you're given angles in degrees, make sure your calculator's in degree mode. Later on in this class, when we get to waves, we'll be doing a lot of, actually before that, when we do rotational motion, we'll be doing a lot of calculations with radians. So if something's in radians, you gotta put your calculator in radian mode. Let's look at another example. Okay, right triangle. With sides 9 and 7. And we don't know the hypotenuse. We don't know, we don't know these 2 angles, A and B. So let's figure out hypotenuse, let's figure out angle A, let's figure out angle B. If you want to pause the video right now and do it on your own, do that, and then you can check your answer against mine. Let's find C, side C first. That's pretty easy. We can use the Pythagorean Theorem. C equals root a squared plus b squared. It's 11.4. And now to find these angles, we can use our trig functions. Maybe say tangent of angle A is opposite divided by adjacent. And remember, the way to figure out A is to do the inverse tangent. So find the inverse tangent function on your calculator, and you should get the angle A is 37.9 degrees. And now angle B, you can simply find from our relationship that the three angles add up to 180. Or if you want, you could use one of the trig functions again. But the quickest way is just to use the sum of the three angles and find that B is 52.1 degrees. Okay, one more example. Let's say that we're given a point on a coordinate system in Cartesian coordinates, and we want to express it in polar coordinates. So our point is here, x and y. It's negative 3.5 meters, comma, negative 2.5 meters. So let's figure out the polar coordinate representation of that point. Meaning, we'll figure out this length, and we'll figure out this angle, r and theta. Probably the easiest way to do it is to just picture this as a right triangle with one side 3.5, one side 2.5, and there's our hypotenuse, which is square root of 3.5 squared plus 2.5 squared. 4.3 meters. And this angle in here, I'll call it angle A, is inverse tangent, opposite over adjacent. Or 35.5 degrees. So this angle A, 35.5 degrees, is this part. And if we add an extra 180 degrees to that, then that's the full angle theta from the x-axis. So theta is A plus 180, which would be 215.5 degrees. So our point that was originally in Cartesian coordinates, minus 3.5, comma 2.5, in polar coordinates, it is 4.3 meters from the origin, and 215.5 degrees with respect to the x-axis.